Bismillahirrahmanirrahim. Our class today on the topic moment of force. So first consider a situation like spanner turning around a fixed nut. Here is the example of spanner to turn the fixed nut. So from here we have give a force at the tip of the spanner to fix the nut. Another example, when we open the door, we have give a force at the doorknob to open the door. So this situation we call that moment of force. So product of the force F and the perpendicular distance D from the line of the action of the force from the fixed axis pivot, the turning effect of the force is called the moment. So for the moment of force, we have force, distance and the pivot. So calculation for moment is F multiplied by D. D is the force, D is the distance and F is the force. Moment is depend on size of the force and the perpendicular distance from the pivot to the line of applied force. If the force is measured in Newton N and the distance in meters M, the unit for moment in SI system is Newton meter and M. Since the moment is a vector, it has both magnitude and direction, where the direction of the moment is usually defined as clockwise or anti-clockwise. Look at example 1. Find the moment about E when the force of 4 Newton is applied at the edge of the point ABC of 3 meter road shown below. We have road here, so we want to find the moment about E when the force is 4 Newton is applied at each of the point A, B and C. So we look at the solution. So when the force is applied at A, so remember formula for moment is force multiplied by distance. So the force is 4 Newton and the distance force at A, so distance is 0. So 4 multiplied by 0 is equal to 0. When the force is applied at B, so the moment equal to force is 4 Newton multiplied by 2 meter. The distance between A and B is 2 meter. So we get 8 Newton meter clockwise. The movement is in the clockwise. When the force is applied at C, so the moment becomes 4 Newton multiplied by the distance here is 2 plus 1, 3 meter. So we get 12 Newton meter clockwise, movement in clockwise. Look at example 2. Two forces are applied at the end A and B of a 5 meter road as shown below. Find the sum of the moment of the force about point A and B. So we have a road here, 5 meter road, and we have two forces here, 3 Newton with angle 30 degree and another force 4 Newton. So we want to find the sum of moment of the force about point A and point B. So first we need to calculate moment about A. So the first force is 3 Newton with 30 degree angle. This one we will calculate the force by using formula sign, because if we transfer this line to here, we want to calculate this line with 3 Newton force, so we will use a sign, opposite over hypotenuse. We will use sign for this force, 3 sine 30 degree. So moment about E, force at the 3 Newton here will be force multiplied by distance. So the force is 3 sine 30 degree multiplied by 0. Distance here is 0, because moment at A, so distance 0, and then plus another force for 4 Newton, 4 Newton multiplied by distance 5 meter, so 4 multiplied by 5. This is clockwise movement, so we get 20 Newton meter clockwise. And then calculate moment about B. So for force 3 Newton here is 3 sine 30 degree, will be multiplied by 5 because distance is 5 clockwise, plus force 4 Newton multiplied by 0. Distance here at B is 0, clockwise movement, so we get 7.5 Newton meter clockwise. Look at example 3. Aziza with a mass 45 kg sit at the end of seesaw 3 meter away from the pivot, while Ali with mass 50 kg on the other side of the seesaw also 3 meter away from the pivot. Find the sum of the moment of the force. So we have the figure here. Aziza and Ali, we have pivot and distance from the pivot and Aziza is 3 meter, also pivot to Ali is 3 meter. So we want to calculate the moment. Find the sum of moment. So the sum of moment, we calculate moment for Aziza plus moment for Ali. So formula for moment is force multiplied by distance. So for the force, just now given from the question, the mass of Aziza is 45 kg, so we need to transfer to SI unit. So 45, just as 45 kg need to multiply by gravity 9.81, so we get value in Newton unit. So the force for Aziza is 45 multiplied by 9.81 multiplied by 3, distance is 3, anti-clockwise, plus moment for Ali 50 kg multiplied by 9.81, so we get Newton multiplied by 3, distance is 3 meter clockwise. So calculate this one. For Aziza is 1324.35 anti-clockwise, plus moment for Ali 1471.5 clockwise. For this question, we need to know principle of the moment. When the seesaw will move clockwise toward Ali, as Ali weight greater than Aziza. If the anti-clockwise is clockwise moment, then the seesaw is balanced. This is the principle of moment. So we need to minus Aziza moment here, so we get the total moment is 1471.5 Newton meter clockwise. Next is principle of moment. The principle of moment state that total clockwise moment will be equal to total anti-clockwise moment. Here system is called equilibrium or balance if total sum of anti-clockwise moment is equal to the total sum of the clockwise moment. All force acting on the system in any direction is 0. Resultant force in any direction is also 0. Example here, we have 150 cm with its ends A and B on smooth spot is at rest. The beam carries mass of 7 kg and 4 kg at distance of 30 cm and 80 cm respectively from A, and the reaction at each support. So here is the diagram for the situation. So first we need to transfer unit 30 cm to meter, 0.3 meter, 0.5 meter and 0.7 meter, and also for the 7 kg need to multiply by gravity 9.81 to get unit Newton, and also for 4 kg multiply by 9.81 Newton. So since the system is equilibrium, so total moment about A will be equal to 0. So we calculate moment for 7 kg, 7.97 multiplied by 981 multiplied by 0.3, distance 0.3, plus moment for 4 kg, 4 multiplied by 9.81 multiplied by 0.8, 0.3 plus 0.5, 0.8, and then minus RB, force at RB, multiplied by 1.5. Distance from here to here is 1.5. So calculate, we get RB is equal to 34.66 Newton. So total moment is equal to 0. So we calculate RA. We can calculate RA. RA minus force for 7 kg minus force 4 kg plus RB. RB just now 34.66. So calculate RE, we get 73.25 Newton. Okay, that's all. Thank you.